And then we kind of discuss the operator overloading, okay, through member functions. Okay, so we so it was a so just like you can do operator overloading through global functions, you can also do operator overloading through member functions. And then we sort of discussed some interesting use cases of so we first of all we saw that you can do operator overloading. So let us maybe go to that particular slide. Yeah. So you can have operator overloading through these three mechanisms basically, right? So you can have it through a global function. Okay. So for example, let us take this plus operator, right? So you can do operator overloading through a global function. So suppose you have two objects A and B of my type. You can do something like an A plus B, okay, by defining this kind of a global function, right? Okay, this is the first one. The second one is you can do it via member function. This we have seen. So in this case, the calling object is basically the first argument. Okay, so yeah, so so basically so in this case, if you are using member function, so binary operator function will take only one argument, because the leftmost argument is going to be the first argument. Okay, sorry, leftmost argument is going to be the implicit argument, which is basically the current object on which this particular function is being called. Okay. Okay. Now there is the we also discussed that there is the third thing, which is basically using a friend function. Okay, so like we discussed, the friend function is not a member function. So again, the friend function will have two arguments, okay, for a binary operator. So for a plus operator, it will have, just like a global function, it will have const my type ampersand and const my type ampersand. Okay, and for the local function, similarly, for a unary function, unary operator, sorry, unary operator, it will have one argument, whereas the member function will not have any argument. Okay. Now, if you do this using a friend function, what we saw last time, so yeah, so you saw that. So this was in the other slides, okay. But what you saw is that this allows you to maintain the encapsulation. That is, you can have the data members of my type as private, because this is a friend function. Okay, and also you can have like you can and but then yeah, so that was one advantage of using the friend function that you are seeing. Okay, now here we will see one more example. I think we also saw this last time, that where it actually helps to further cases which cannot be achieved using let's say a member function. Okay, so remember, member function is also able to also allows you to keep the encapsulation, that is, you can keep the data members private. Okay, and that case is, as we discussed I think last time also, that it is this particular case, okay, which is that you are trying to do an overloading of complex number type. Okay, but you also want to allow doubles to be added to complex. Okay, and in that case, okay, it is, the first two are fine when you say, so D1, D2, D3 are of type complex, and this 6.2 is basically of type double, obviously. Okay, so what you can do is you can do this D3 is equal to D1 plus D2. Okay, This is allowed. Okay. You can also do D3 is equal to D1 plus 6.2, because all you have to do is you have to overload the operator function with with an argument double D. Okay. So these two are fine, but this is not allowed. Okay. So if you want to do 4.2 plus D2, this is not allowed. Okay. So this is a handicap of the member function approach to overloading operator, where the first argument needs to be of the type in which you are defining the member function, right? Okay. So now this problem is solved by using the friend function. Okay. So this is the previous example where what you have done, you have used basically three types of operator function. So it also looks very, very simple. You see, basically three overloads of operator function, you can say. The first one takes two complexes. The second one takes the first argument as a complex and second argument as double. And the third one takes the first argument as double and the second argument as complex. Okay. And the implementation is, it's obvious, it's pretty simple. So, yeah, so in the end, you see, you can now basically have statements of all three types and things will be done correctly. Okay. Okay. Now, here, one thing to note is that so what we discussed, that if we use this explicit constructor, what this means is that the casting to this particular type, okay, has to be done explicitly. Okay. So for example, this constructor allows you to cast a real number into a complex correctly, right? Because what will it do? It will simply set the imaginary component is equal to 0. So you can call this particular constructor with just one double, and that will be set to R. Okay. But this explicit keyword prohibits this particular conversion in an implicit manner. For example, in this particular case. Okay, so in this particular case, 4.2 will not be implicitly cast to double. Okay, but suppose if you remove this explicit, okay, then this can be done. Okay, and then you need to define only the first one. Okay, if you define only the first one, okay, you can still get all these three statements working. Okay, because in the second statement, this 6.2 will be implicitly converted to complex, and in this statement this 4.2 will be implicitly converted to complex. So in this case it will work. Okay, but what will but this way of doing things, I mean, you lose control over how exactly things are happening. Okay, so in this particular case it so happens that it will work fine, but in other cases it may not. Okay, so so this explicit keyword is also useful when you don't want such implicit conversions. Okay. Okay. Okay, so yeah, okay, so now we come to again this particular case of overloading the IO operators. Okay, so okay, so basically you have this less than operator, or you can also think of it in C, it is also sometimes called the left shift operator, right? So so this less than operator, okay, in C++, as you all know, has been overloaded to actually perform the IO operation. So you can do something like cout left arrow D1. So if we just look at this portion, okay, what it does is it basically, so for any D1 object, it actually prints it to the output stream. Okay, so this basically converts it into a string, which is put into the output stream, and then basically so cout is of type OStream. Okay, so cout is an object of type OStream. Okay, and then it eventually gets printed, okay, through this object. Okay, and what happens is basically that this can be chained also. Okay, so this is the key thing about this particular less than operator. Okay, so so earlier, so how will you overload this less than operator? So this is basically a way of overloading the less than operator. So let's say you want to overload it for the complex type. Then what you do is the first argument is an object of type OStream. Okay, and the second argument is an object of type complex. Okay, and what you do is basically you print this complex into this OStream, and the resultant OStream is the resultant OStream object is what you return. Okay, okay, and you can also do this using member function like this, that basically this operator is overloaded for the OStream object type. So the first argument is of type OStream. Okay, and you can do it like this. Okay, okay, yeah. So so the object to write is passed by constant reference. Okay, and return is by reference, because so you cannot return by constant reference simply because you are basically changing the so you are allowing the so you are allowing this OStream object to be changed. Okay, so so this is the reason. Okay, this we have seen. Okay, so here so here we are showing with global function both OStream and IStream being being overwritten, being overloaded. Okay, so how are we doing it? If you see, in case of IStream, it is similar. In case of greater than, which is the input operator, you can say. Okay, it is overloaded for the IStream object. Okay, so as the IStream, so the leftmost argument is an IStream object. Okay, and the right argument is again the object to be written. Okay, and what you basically do is you just read the real part followed by the imaginary part. Okay, and here you just write the real part first onto the OStream object followed by the plus j, and then you write the imaginary part. Okay, so this is how you are overloading. So this particular code will work, that you can say complex D, and then you can say scene D, scene greater than D, and then cout less than D. Okay. So only problem is that the encapsulation is broken, because you have to declare both real and imaginary as public. Okay. Now, if we try to use a member function, okay, how will we do this? So, so we will do it something like this. Okay. Okay. So here now there is a problem. Okay. So what is the problem? Problem is that you see this OStream operator, this OStream class is a standard class. Okay. So this is a class that has been defined in the library. Okay, So you cannot really introduce a member function in this class. Okay, so this is a problem. Okay, so okay, so this is one problem. Okay, okay, so okay, so what can you do? You can also define. You can also, of course, overload the less than operator for the complex class, but then it will spoil the spoil the syntax. Okay, so you have to write something like d less than cout. Okay, which is obviously not a good idea. Okay. Okay, so the question is can we try to uh, uh, okay uh, okay okay, so this particular okay, so okay, okay, so can we try to so can we do this using the friend class, right? So so I don't have the slide here. Okay, but as you can imagine, what you yeah, so in this case, so I will add this particular slide here. Okay, but so as you can imagine, what you can do, you can make this OStream class, okay, a friend class in the in the complex class. Okay, so if you do so, then you are able to access the so you are able to basically access the yeah, so you are, so actually you are able to just write, sorry, not OStream class as friend class, but what you do is you make this overloaded operator function a friend function in the complex class. Okay, and in that case, so let me just show you the global version. Okay, so just this global version, okay, you can make it a friend function inside the complex class. Okay, and then your encapsulation is also valid. Okay, and you are everything basically works. Okay, so I hope this is clear. Is there any question on this part?
Could you please explain the case 2 again of the overloading?
This one?
Yes, sir.
Yeah, so it is so see now so what we are saying, so we are trying to overload the less than operator. Okay, now without breaking the encapsulation. So how do we do it? So we are so this case 2 is again a failed case. Okay, so this is not a good case, or this will not work. Okay, but how are we trying to do it? So we are saying that we will overload this operator inside the as a member function inside the complex class. Is this clear? So this is what we are trying. Okay, if we do that, what do we know? We know that the first argument will always be of type complex, because we are doing it as a member function of the complex class. Okay, if this is the case, if you see, how should my when I'm using it in a function, how will I have to use it? I have to use it like this, because my first type has to be complex. So left operand here has to be of type complex, and the next operand has to be of type OStream. Clear? So this,
okay, sir, got it, sir.
This yes, breaks the, yeah. So this breaks the order, because normally you would use it as cout less than d. But if you overload like this, you have to use it as d less than cout. Okay, so this is not going to work. Okay, so this spoils the syntax. Okay, that is why the second case is not a good case. Okay, so now you see here. Okay, so what are basically so some of the guidelines for operator overloading? Okay, so so the first thing is that use a global function when encapsulation is not a concern. Okay, so if your class is something that you are not encapsulating, okay, something like, let's say you're defining a string or something to wrap a C string, you can just overload the global operator. Okay, no problem. But if you are doing the overloading, okay, first thing you can try it with the member function. So when can you use the member function? You can use the member function way of overloading if the left operand is necessarily a class where the operator function is a member function. Okay, and multiple types of operands are not involved. Okay, so so left operand you cannot change the type. Okay, so in this particular case you can use a member function. Okay, otherwise you can use a friend function. Okay, friend function works with everything. Okay, for operator overloading. Okay, and some general guidelines. Okay, so when you are doing an operator overloading, you should try to preserve its natural semantics. Okay, so basically, plus, so for example, if you are, so we have discussed this, right? So if you are doing overloading the plus operator for the for matrices, let's say, it should only denote matrix addition. Okay, or yeah, and so on and so forth. Okay, so for example, in this case, in case of set, it should probably denote union and not intersection. Okay, okay, yeah. So now yeah, so usually stick to parameter passing conventions. Okay, so yeah, so built-in types should be passed by value, and user-defined types should be passed by constant reference. Again, this you must have noticed multiple times in the codes that we have discussed, and you understand the reason, right? So built-in type, there is no point in there is no advantages in passing them by constant reference, so you might as well pass them by values. Okay, and user-defined types like classes, you can basically pass by constant reference, unless you want that to be changed. So you have seen also that some special cases where if the user, for some reason, if the user-defined type object needs to be changed, then you have to pass it not by constant reference but by only reference. Okay, yeah, so this is this is one thing. Okay, yeah, so decide on the return time based on the natural semantics for built-in types. Okay, for example, as in case of pre-increment and post-increment operators. So we have seen this. Okay, so how you do the return type. Okay, yeah. You should consider the effect of casting on operands. So remember that when you are overloading an operator, okay, just like in case of, so you are basically overloading the function operator, okay, and you can understand that the arguments can also go through a natural casting mechanism. So you should understand this and accordingly, interpret the behavior of the casting. The case, so we have discussed one such case, right? With the complex. Okay, and the last is, okay, so you should only overload operators when, so you should remember that you can always have the functionality made available through a function, right? So you should, the operator is an added incentive because you can write very natural programs. Okay, so if things are not happening naturally, you can always make a particular functionality available through member functions, and you don't have to provide overload operators for every functionality. Okay, Okay, so yeah, so with this we stop. So any questions about overloading, operator overloading, and in general user-defined types? Okay, so as you can see, I mean, through the examples that we have gone through, okay, so you can basically you can define a lot of I mean, you can define very natural syntax for user-defined types using this particular semantics. Okay, so yeah, so I think this part is clear. Okay. Um, okay, so now let me go into quickly a particular feature which is again specific to C++, and we have discussed about this feature, which is the namespace feature. Okay, okay. So what is the yeah? So what is a namespace? Okay. So a namespace is a declarative region, okay, which provides a scope to its identifiers. Okay, so this includes names of types, okay, which is like classes, okay, functions and variables. Okay, so all three types of things can be qualified by a namespace. Okay, so this is the concept of namespace. It is used to organize code into logical groups, okay, and then to prevent name collisions that can occur, especially when your code base includes multiple libraries. Okay, so yeah, so we'll see some examples. Okay, so namespace provides a class-like modularization without a class-like semantics. Okay, so we'll discuss this. Okay, and it obligates the use of file level scoping of C, like using the static variables. Okay, so yeah. Okay, so in C you can basically do a file level scoping of functions by declaring them as static, right? So so that is kind of not needed in C++. Okay. Um, okay, so let us see an example how how you can define a namespace. So this is the program. So what you have done, you can just say something like this, that namespace, my namespace, okay, and inside it you can define a data. Okay, this is like any data that you would define. You can define a function. Okay, you can define a class, etc. Okay, and then you can close the namespace. Okay, so this basically says that the scope of the namespace is now closed. Okay, but then inside the main, okay, where you are actually using the std namespace, because here you have said using namespace std. So inside the main you are using the std namespace, but you can access something that you have defined inside this my namespace by using my namespace : my data. Okay, so this : operator is basically used to qualify the namespace of a particular data or function or type, okay, which is class. Okay, so as you can see, you can do data like this, okay, and you can print data like this. So this is and this is so now your variable has become, so the name of the variable has basically become my namespace : my data. So this is now your variable. Okay, similarly the name of the function has become my namespace : my function. Okay, and similarly the name of the type which you defined by defining this class called my class, okay, has now become my namespace : my class, okay, as you can see here, okay. And you can define objects of this type. You can do all the operations as usual, okay. So yeah, so a name is a namespace is prefixed by the name of it, okay. Beyond the scope resolution, all namespace items are treated as global. So you don't have those access specification and those kind of thing. Everything is global, okay. Just that it is residing inside this particular namespace. That is the only thing, okay. Okay. Yeah. Okay. Any questions? Okay. So okay. Now let us look at this example that this cstdlib has this function called int abs. Okay. That returns the absolute value of the parameter n. Okay. So if you pass it a parameter n, suppose you need to do that. You need to define a special ABS function that returns absolute value if it is between -128 to 127. Otherwise, it just returns 0. Okay. So you define this. So this left side of code is what it's in C. You define or in C++ also you can define something like this. Okay. Now you are defining this new ABS. Now what has happened? You have so there was this another ABS that was defined, okay, but now that ABS, the original ABS has been lost, okay. So now if you call this particular ABS function, so there is basically no way of calling the original ABS function. Okay, so it has kind of been overridden, you can say, by this particular definition of ABS function. Okay, so this is what will be used. Okay, but now, okay, yeah. So this is what will happen. Okay, but you can avoid this problem, okay, by creating this new ABS function inside your namespace. Okay, so you can define a my namespace, my NS, okay, and then inside it you can define this ABS function. Okay, so what you can do, you can print both this my NS : ABS, okay, and this will work, or your standard something which is there in the global namespace, not even in the. So notice that we are not saying that using namespace std here. Okay, so we are actually not using the std namespace here. Okay. Okay, so basically this function is in the global namespace, and you can basically access this particular function by just saying ABS. Okay, so both functions you are able to access. Okay, so okay, so yeah, so now. Here is another utilities, or like the situation where namespace will most likely be used, or the biggest use case of namespace. Okay, so suppose an organization is developing an application to process student records. Okay, and yeah, so you have class ST for students and class ST-reg for list of students. Okay, so these are the two classes. So you have class ST here. Okay, and you have class students registered here. Okay, so you have a list of students and you have the number of students, and each student here has gender, name, and so on and so forth. So, and it has the output operator overloaded, etc. Okay, so okay, okay, okay. Now, so these classes are included in header file. Let's say students.h. Okay. Now, you see, now this students.h is kind of a library. Okay, so it is being used by two engineers. Okay, so let's say Shobita and Niloy. Okay, and they are sort of developing different applications. Okay, and both of them they write this function process students. Okay, so what will happen? So they have done some implementation. So in this case, they have done exactly the same implementation. Okay, but now think about. So generally in projects there will be like a project lead or somebody who will be responsible for integrating, let's say, the project. Okay, so typically different engineers will be working on different versions of the project or different portions of the project, and then the whole code base has to come together and the whole thing has to be built together. Okay, now let's say Purnima is doing this building. Okay, okay, and basically they are sort of she's trying to compile this whole thing. Okay, now what will happen? There will be this name clash, right? So this so there will be two functions by the name process students. Okay, and so now what does Purnima do? Okay, so what does Purnima do to build the this thing? So in this case, the individual codes will get built for both Sabita and Niloy. Okay, but for Purnima, there will be a name clash and there will be a there is a problem in integrating the code. Okay, so how does Purnima then integrate this these two codes given by Shobita and Niloy? Okay, so what she can do now, okay, she can simply say something like this, that she can take the code from Shobita and put it in one namespace. Okay, just let's call this app1. Okay, and this can be put in another namespace and call it app2. Okay, and now while integrating in the main, she just has to say app1 : process students and app2 : process students. Okay, and basically she is guaranteed that this will exactly work. So if you see, these files were generated by two different developers. All she has done is she has put this entire app1.cpp inside one of the namespace, inside the app1 namespace, or she can also instruct the developers that put your thing inside your namespace and this too inside another namespace. Okay, and then she can easily just call. So it's a very easy integration. Okay, so it's a very easy way to integrate. Okay, yeah, so this is probably one of the biggest use of one of the so this is a huge I mean, in practical scenarios this will solve a lot of problems. Okay, yeah, so for small projects you will actually not realize probably if if there is a very tight team which is working together, like let's say 2 people, 3 people. So this is a toy example that I'm talking about. But as the team size increases, I mean, you can imagine that this will solve. So this provides a very principled way or a technique to actually keep code separate and very easy way to integrate codes from different developers. Okay. Okay. So now you see, so what we are showing here is okay. So basically, so one thing is that just like classes, okay, namespaces can also be nested inside C++. Okay, so this is the other thing that you can have something like maybe a team team namespace followed by let's say a namespace of an individual subgroup, and then followed by a namespace of a developer. Okay, so you can do something like this. Okay. 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 So yeah, so and basically the way to access it is also, you can see, very simple. So you do the top level namespace : the next level namespace : data. So this is how you access variables, functions, or types declared within nested namespaces. Okay, so yeah, so so I think it is clear. Okay, and remember that this is only the namespace. So here there is no access restriction. So any of these things can be accessed from anywhere, just that there is a very clear naming convention. Okay. 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 So now yeah. So yeah. So also using namespace, we can avoid lengthy prefixes. Okay. So okay. So yeah. So what you can do, you can have, let's say, suppose you have yeah. So we have said that we have already used this particular feature. So this is the using feature of namespace. Okay, so you can just say using namespace something. Okay, so if you say, let's say, using namespace name1, so all symbols of the namespace name1 are available. Okay, and so you can say v11. So this will basically be interpreted as name1 : v11. Okay, and or v11, let's say. Okay, and similarly you can say v21 and yeah. So okay, so in this case, you see, we have included now this name2 : v21. So we have only included v21 symbol from the namespace name2. Okay, now here yeah, so v21 basically refers to this name2 : v21. Okay, but if you try to access v22, okay, then it will be treated as undefined, because v22 is not defined in this particular namespace. Okay?
Excuse me, sir.
Yes.
Sir, if in the namespace name2, if we have a variable named v11, so it is different. But if we define it like v21, so there will be an ambiguity if we are not using the namespace.
Yes, yes. So which is why so there will be an ambiguity. Okay. So which is, I mean, so you should so see what is the feature that is being given to you, right? So the feature that is being given is that, so first of all, you can use many different libraries. All libraries can be there in their own namespaces. Okay, so you need not, in order to use, let's say, suppose a particular library, you want to use only a specific function. Okay, so you should only I mean, you can either do, let's say, if you are using that function only a few number of times. Okay, so what you can do, so in that case, you don't need to use using thing here. Okay, so all you do is you access that function as namespace : name of the function. Okay, so then there is no confusion. Okay. Now, if you want to use using, okay, then what you do, you can also include specific functions. So there may be, let's say this name2 as, as the example was given by you, that suppose name2 also has v11, okay, but you know that name1 has v11 and you are already using namespace name1, okay, so you know that already there is a v11 now in your which is available to you, okay. So if you include another v11 from name2, then there will be a clash. So there will be yeah. So what you so what you can do, you can simply import the particular v21 in the like here, okay. So then you are not having a clash. But if you are having v11 in name2 also, then if you try to say using namespace name2, then there will be a clash, okay. So you cannot do that. So one of them you have to use by qualifying the name.
So before using, applying using, we have to make sure that the two namespaces should have the different variable names to avoid ambiguity.
No, you don't have to make sure. Okay, so I think there will be a clash. Okay, so one way is you can resolve the clash by using still the namespace. So that is still available. Okay, so you can still resolve the clash by using the namespace. Okay, if you are saying that you are using you are sort of using two namespaces and both have different variables, right? So you can still resolve the class. So first of all, you should know which variable you are using. Otherwise, there is no point, right? So you should know which variable you are using. So if you are in confusion that which variable is being called, so one thing is, as far as I understand, if you refer to a variable without without any namespace qualification, the last namespace which has been included or which you have added, that variable will be referred to by default, okay. But what you can do, you can still use the variable of a previous namespace by saying name1 : that variable name.
Yes, sir.
Okay. 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 So yeah. So whenever you have confusion that so the way to do it is, whenever you have confusion that there might be name clashes between namespaces, you can explicitly qualify the name of a particular variable using the namespace. Okay. So that option is always available to you. Okay. So I think yeah. And so this is another example, okay, where you see you have data in the global namespace, okay, and you also have data in namespace 1, okay. So you can access the data in the global namespace by simply saying : data, okay. So you can access this by saying name1 : data, okay. And you can access the global name by saying : data, okay. Okay, so okay, okay. So now yeah, so now here is the other thing. I think this part you already know, okay. So the entire C++ standard library has been put in its own namespace called the std, okay. So that is why when you when you want to use functions or objects from this IOStream library, you have to either, so if you don't say using namespace std, then you have to say std : cout, and then it will your code will work. Or you normally what you do is you say unique using namespace std, so then all the symbols or all the names from this namespace std are available to you for use. Okay. Okay, yeah, and namespaces are open in the sense that, so suppose you can do the following thing, that you can, let's say, define a namespace open and define one variable inside that namespace. Then you close the scope, okay? Later, somewhere again, you can define the namespace open and define another variable inside it, okay? So both variables, so when you say using namespace open here, both x and y variables will be available to you. So these variables inside namespace open will be available to you. So basically, names keep getting added to the namespace, and you can do it at multiple places. Namespace open here, both x and y variables will be available to you. So these variables inside namespace open will be available to you. So basically, names keep getting added to the namespace, and you can do it at multiple places. Okay. This is, you can understand this, right? So you can, so you can just add things to a particular namespace. Okay. Okay, so so here is a comparative between namespace. So I think we have also discussed this many times. So every namespace is not a class, but every class defines a namespace. Okay, so this we have seen. Okay, a namespace can be reopened and more declaration added to it, like we just discussed. Okay, class cannot, with a class that cannot be. So once you do a class definition, you cannot say at a later time that the same class I will now again add some more data members or functions. That you cannot do. You have to do it in one place. Okay, no instance of namespace can be created, of course. Yeah, so class can have multiple instances. Using declarations can be used to shortcut namespace qualification. Okay, but in class you cannot do that. Okay, so even though class declares a namespace, you cannot do using to actually use that. Okay. And namespace may be unnamed. Okay, which is what we saw, that the global namespace is actually unnamed. Okay, but you cannot have an unnamed class. Okay. Okay. So basically, what we are talking about here is a lexical scope. Okay, so a scope is basically, as you all know, it is whatever you define. So there are different types of scopes that you can talk about. Okay, okay, so you can so you can have different scopes. Okay, so first is you can have an expression scope. Okay, so restricted to only one expression. Okay, so this is something as a programmer you wouldn't use, but compiler can use it. Okay, then you have the block scope. Okay, so you have seen that you can define a block using open bracket and close bracket to create a local context, and within that scope you can define some names, and those names will be available only within that particular scope. Okay, then you have seen this function scope. Okay, so a function creates a scope. Okay, then you have seen that a class also creates a scope. So we remember we discussed this, right? So inside the class scope, names of that particular scope are available. Okay, then we just discussed this namespace scope. Okay, so namespace is basically a grouping of symbols for code organization. Okay, then there is a file scope. So inside a single file you can have multiple classes, functions, etc. Okay, okay, so this is like it limits the symbols to a particular file, and then of course, you have the global scope. So these are kind of the different types of scopes that you encounter while so while binding a name to something. Okay, so for example, you can associate a name with a variable, or you can associate a name with a function, or you can associate a name with a type, right? So name is just a word. Okay, so when doing binding, the compiler basically supports these different scopes, and how things bind. We have discussed some of this within the scope. I mean, so always the most local scope is taken into account. Okay. Okay. Yeah. So any question regarding? Yeah. So okay. So yeah. So yeah. So again, scopes can be named or unnamed. Okay. Yeah. So some of the named scopes are this class scopes, namespace scope, and global scope. Okay. So others are you can have unnamed scopes. So these scopes don't have names. Okay. And also scopes may be nested. So blocks, class, and namespace, these can be nested. Okay, so you can have a scope within another scope. So the previous scope, yeah, so this is how it is. Okay, some scopes cannot be nested. Okay, so for example, functions cannot be nested, expressions cannot be nested, files, obviously, file and global cannot be nested. Okay. Okay. Okay, yeah. So we have understood namespace. Yeah. So I think we are out of time also. So we have yeah. So understood the namespace. We have understood some typical scenarios where namespace helps. Okay. And we have understood how namespace is placed in respect of different lexical scopes of C++. Okay. So with this, I will stop. Any questions?
So is there a performance cost of including a namespace, like using namespace standard? Then are we importing all the functions of std inside the main in a program?
Okay. So is there a performance implication? No. So see, the thing is that this all happens in the compile time, right? So for C++, there is no performance implication like this. But yeah, in some other languages, there is a performance implication because yeah, because it's interpreted. In interpreted languages, it happens. So like Python, there is a performance implication, but not in C++. Yeah, because all this gets resolved at the compile time. Okay then. Okay. Thank you very much, everyone.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.